I have one of our team members, Eric, who's a real electrician, because believe I'm not an electrician. I taught myself all of this, believe it or not. I'm an engineer, but I didn't know any of this stuff at all. Through pain and disappointment, I actually learned this stuff through necessity and just wanting to have a reliable electrical system. And yeah, I bought my boat on April Fool's Day, by the way. It's a 1990. I love her. I know it's weird, but I do really love her. She's the one thing that makes me happier. I literally go on that boat and I'm a different person. It changes me. I go from being so intense to the person I was when I was probably in high school and I didn't think about my future and I was living in the moment. And yeah, she's awesome. She's amazing. Absolutely amazing. But so what I meant to say is Eric's coming here today and he's going to be joining us and he's going to be showing you, because Eric and a lot of my team members, well, most of them, this is what they do for a living. Like I've stopped making crimps for a living in 2010 and now I just talk and I come up with ideas, and luckily my team members actually execute on those ideas. And they make it happen. So there's a really big difference between thinking about something and doing it, and that's why electricians make a living, because they're used to making things happen. So first thing I want to emphasize, when you're ever going to be working on your boat electrically, and this is something that everyone should want to do. I don't think it's too daunting to do electrical on your boat. That being said, you also want to respect it, right? Respect is important. Give you an example. I've come across many boats where the owner was very technical, an engineer, might have even been an electrical engineer, and it were complete disasters. Complete disasters. And I've been on other boats where the owner's an accountant, has no technical background, and the boat was perfect. It doesn't matter what you did in school, it doesn't matter what you do for a living, it doesn't matter, all of those doesn't matter. If you care about doing something properly, there's enough information out there for you to do it right. The challenge that we all face, because we don't have enough time, is to do bravado and MacGyver and just get it done. That is our enemy. And when you're going to be working electrically, don't ever feel rushed, because you only need one mistake with electrical and it's one mistake too many, right? It's a perfection business. If you're not in the perfection business, you can't be, it's like being in software. If you're writing software code and you don't care about details, you're not going to be a software coder. It's just not going to compile. It's being an accountant and not caring where the decimal points are. You know, oh, it's a little bit to the left, a little bit to the right. It's the same numbers. I just moved the decimal. It's just really order of magnitude. It matters. So electrical is about details. So with that in mind, we're going to be talking about safety. So it's very, very important when you're tackling electrical to care about the details. These are examples of one of them was done by an electrical engineer. The one on the left, I asked permission. I would never say his name, but he was humbled by it. He said, it wasn't really going in there really well. It was giving me a lot of grief. Notice the white wire, how bunched up it is? He was trying to fit it in the plug and it wasn't going in, so he didn't give up and it starts becoming stubby, and he kind of did it and it went in slightly, and he's like, oh look, my panel's lit up, I did it. And then about a month later it stopped working. He's lucky, he could have had a fire because his neutral was off and he was running everything on his ground. So his 3-wire system was down to 2-wire and he was using his AC grounding wire as his return path. Very, very serious. He noticed because the neutral polarity light on his panel was always lit. But he thought he was unlucky there too. It was just a coincidence. Notice, simple as a 12-volt cigarette lighter. Notice on the right-hand side how the insulator, right, is actually not in between the metal. It's on the side. Can you see that? Look at this. Right here. You see how the connector is actually not inside? He actually put it in between the metal and the plastic. Because sometimes it's hard to see, right? You just want to get it done. So the point I was talking about is there's a high standard. You know, you're not measured with how many things you get right in electrical, you're measured with how many things you get wrong. It's unfair, but that's what it is. Doesn't matter that you got 1,000 connections right. You get one wrong, that's one too many. So you've got to be okay with that. And that means that you have to believe and come to grips with the fact that perfection is the name of the game with marine electrical. Some of it means it might not work and you don't care, but sometimes certain things on our boats are really required. Like, for example, a navigation light. You might get stuck one day coming late into port, and if your navigation light runs out, not all the boats have radar and they might not see you. That might be a life and death situation. As simple as a light bulb not working, life and death situation. And it could go as bad as a wire dead short and a fire, which is sort of extreme, but it could be you lose your chart plotter because the seas are bumping, and every time your boat is going up and down the face of a wave, your chart plotter goes in and out. That could happen. That could also be pretty stressful. So you really want to make sure that you don't create these unreliable situations in your boat, because most of us find boating challenging enough as it is in a perfect boat. It's pretty humbling to own a boat. We all get it. We all know what it is. It doesn't matter how successful you are on land. You're going to find out that boating is a very humbling activity, pastime, and you don't need to make it worse than it needs to be. You want to offset issues with corrosion, and we're going to be talking about insulation and how important that is. And the other thing too that's very disconcerting, and it's a reality, is that a connection under no load is probably going to work, but under load, as soon as the connection loads up and you start using that load and it becomes a bigger load, you might have crazy voltage drop. I've had situations where you measure the voltage at the fridge is 12, and as soon as the fridge turns on, it's 2 volts because it was a really bad crimp. Under no load, you could measure 12 volts, no problem. But as soon as there was a load, the voltage dropped really down. So that's a big issue. And sometimes your breaker might not trip, but you might have a fire. That's why those shore power plugs on the boats, where it's the #1 cause of boat fires, they've got a 30 amp breaker on the pedestal and a 30 amp breaker on the boat, and your pedestal, like wherever it is on your boat, that 30 amp receptacle could literally catch on fire, and your breaker on both the dock and the boat will never trip. So breakers don't always trip. They only trip for overcurrent. If you have too much resistance in a circuit, that's not going to trip the breaker. So that's also a reality, right? So don't think, it's not because I have a seatbelt in my car that I drive like a maniac, right? I mean, you see people that can have a seatbelt, you can have airbags, you can still get pretty hurt. So don't think because you have a breaker on your boat that you're like, oh, well, it doesn't matter what I do. I'm good. Because boats, you can have an electrical fire without actually tripping a breaker. I took this, and this was unbelievable, doing an electrical audit, and I noticed the fuse block was really corroded, and I actually touched the wire, and the wire fell off. And I was like, I always ask, do you mind if I take a picture? This is too awesome. I have a folder of this stuff, hundreds of bad pictures. I call them great pictures. So that's why it's really important when you're doing a marine connection that you think about you're on the water in a salt environment, and salt is corrosive. So you want to take the time to make sure that your insulation is done properly. So what's the formula for success? You want to make sure you have a good marine wire. You've got proper terminals, right? That you're going to have, if the terminal doesn't come with heat shrink, you actually have heat shrink with it, maybe a lug. You have the right tools, and Eric is going to show you the right technique because he knows what he's doing. Like I said, I just do a lot of talking. These are examples. Notice here, this is crazy. And I see this all the time, by the way. Like you would not believe. People are buying heat shrink terminals, and they're not applying heat to shrink the terminal. And therefore, they're thinking that they're buying a $2 connector instead of a 10-cent connector. And they think that the name is descriptive. It tells you what to do. There's not very few things in life that come in the name, the action that's required to make it useful. Heat shrink terminal. Apply heat to shrink so that your terminal becomes protected. I mean, it's amazing, but that's not enough. I would say you cannot believe the number of terminals I find on boats that have heat shrink terminals that are $2 a pop versus that are never applied heat. And therefore, it's as good as a 10 cents terminal because it's open to air. And open to air means it's going to corrode. So if you, and this is a big thing too, if you're going to do marine grade wiring, you're going to want to make sure that you use standardized colors, that it's able to withstand vibration, that it's easy to install, it's not rigid like a coat hanger, and that you use the right cable for the right application. If you're actually going outside for solar wiring, we're actually using wiring that's made for outdoors so that it can handle the sun. And if we're inside a boat, we're going to use maybe wiring that's meant to go through an engine room, right? So you got to make sure that do not buy the least expensive wiring you can find and think you got a deal. You got the less expensive wire, and it is what it is. By the way, wiring is a very commodity-based business, okay? It's not like someone's going to find a deal out there. There is no deals. The least expensive stuff is the worst stuff. The most expensive stuff is the best stuff. It is what it is. It's a very even playing field. There are no deals to be found. And so don't cheap out. And the reason I say that, because the most valuable thing we have is time. And as a boat owner, if you're diligent, there's a long list of things to do on your boat. And the last thing you want to do is repeat what you did 5 years ago because you bought a wire that's not good quality, right? Here's an example of someone that had a lot of persistence. He was a true believer. By the way, this is a 20 amp breaker. Look at this wire. This is a gauge 8 wire. This is a gauge 10, 12. Notice the number of strands he put in there. He put 2 strands because it didn't fit. This is definitely not a marine grade wiring. You can see the strands are way too big. He cut them all with pair of pliers, so he did a good job. He didn't leave them hanging. He got 2 strands in, bingo. He was like, I did it. Unrelated though, his icebox conversion was not running properly and was cutting out too soon, related to a bad connection. And that's how I saw that. I was like, well, I found your problem. Someone who installed your fridge put a gauge 8 wire, which is great to offset voltage drop. Awesome, that's what I would have done. Didn't have the right terminal, decided to become a MacGyver, got it done, put the wrong ring terminal there, and now under load, when it's low voltage, your fridge cuts out. So, welcome to the world of pain. So the other thing too, and what I always emphasize is, on all our boats, we should have a set of, like on my boat, I mean, it's almost a mobile shop. I have everything. Now, okay, of course it's too much, and I have someone who's understanding, who doesn't mind giving away a lot of drawers for a lot of tools. But that being said, we should have a bunch of different ring terminals on our boats of different sizes, so that if you ever are going to do electrical work, you open a little, sort of like a bait and tackle, right? Little plastic container with little separation. Like I literally have about 15 of those on my boat, every fastener size, every terminal size, like everything, because I never want to do something twice. If I'm going to do it, I want to do it right, and I want to use the right equipment. But bearing that extreme end where I am at, having a small little toolkit on your boat with a bunch of marine connectors, so that if you're going to tackle the work when you're up in Desolation Sound or Gulf Islands and you're changing your water pump, that you have the right butt connector or right wing connector is really, really useful. By the way, a bad crimp over time causes heat. This is look at that connector. That was a bad crimp. Look what happened. I've seen on some wires, even like inverter wiring, where the insulation of the wire has melted like 2, 3, 4 inches back, literally like a cigar, all charred. Bad connection. Make sure that you heat shrink all your connections, and Eric is going to be showing that. Make sure that you use heat shrink that follows the code. Don't confuse and buy black everything, because some people are using black. They'll wire their whole boat in black cable, and they're going to put either red or black heat shrink as a way to start reminding themselves that a black wire is actually positive if it's got red heat shrink on it. There's no shortcuts. People shouldn't take shortcuts. In our shop, we actually use literally red for positive, yellow for negative, yellow heat shrink, right? We use the right heat shrink for the right application. We're consistent, because I want to make it easy for the next person that comes on board to just not have to think. It doesn't want to be context driven. It just, oh yeah, red is red and yellow is DC negative. Other example of crazy bad crimps that I've seen. By the way, I've seen a boat once, and I got a call. This was about 4 years ago. Chris, around this time. Owner was from California, came on board his boat, started the heaters. He was a surgeon from San Fran. He had an Activa 52. Beautiful boat, brand new boat. I don't know, 2 million, 1 million, I don't know. It was awesome. It was ridiculous. He calls me, he says, you know, Jeff, he says, I don't smell burning, but my wife has got a really good sense of smell. And she's smelling burning, but I don't see any fire. And I remember I was in Cole Harbor, and one of our staff, Scott, was actually in Cole Harbor as well. I said, oh my God, you got to disconnect your shore power cord. He's like, what? I don't smell fire. I'm like, no. You got to do it like now. So he went out, disconnected shore power cord. We came on board. He was drawing so much current through his shore power cord to run the AC heaters on board to keep the boat warm, right, in January. And there had been a bad crimp, brand new boat, by the way. But in the summer, he's never drawing that much power, right? What is he running? There's nothing much to run. In the wintertime, first time, this is a brand new boat. That crimp was a bad crimp. It actually melted, and these are huge, like 50 amp breakers, side by side on the panel, and the panel's like this big. 3 of the breakers had melted in the back. There was so much heat being generated. The breakers never tripped. There's never overcurrent. He could have lost his boat. It's only because his wife smelled it. He couldn't smell it. And so you can actually have a bad crimp cause a breaker to melt at a breaker, and yet you don't trip the breaker. So if you're going to tackle all of this, what you want to do is you want to have the right tools, right? You don't want to have a pair of pliers to try to do a crimp. First thing you're going to want to do is you're going to want to have some sort of wire stripper, which is really important. We only use the one on the left. I've never used sort of the gadget one on the right. Eric, have you ever used that? No. I've only used the one on the left. And then you're going to want to have a good crimper. I think we have both, right? You're going to want what's called a double crimp ratcheting tool. And what's really nice about the one on the left is actually going to crimp on one side deeper and stronger than the other. So the insulation is not going to be over crimped. You're going to have one side of the barrel that's going to be crimped really well, which is the metal. And then the insulation on the other one's going to be a little bit less. Or you can use this single crimp ratcheting tool for heat shrink terminals so that you don't break the insulation. And Eric's got both. So when we do work, I only do heat shrink. I figure the most important thing is time. You never want to redo anything on a boat. And my boat's 1990, and I don't think she's old at all. I met an owner yesterday. He said he had a 2008 boat. I'm like, oh, that's a brand new boat. 10-year-old boat is a brand new boat. Literally, it's brand new. Like, none of us buys a brand new boat. Maybe. But that's beyond brand new. 20-year-old boat is not an old boat. 30-year-old boat's not an old boat. 40-year-old boat's not an old boat. An old boat is a 1938 Chris Craft. And she's awesome. And people love them. They don't stop loving boats. So a boat that's pre-war is still out there. So if you're doing something on your boat, I've worked on boats that are from 1918, and those are awesome boats. I've never called the boat an old boat. It's sort of like, you know, and so when you think about what people are willing to do on land, and people say, well, it's good enough for a truck, Jeff. I'm like, how many big rigs are you seeing that are from 1954 pushing loads on the roads? Big rig is 5 years, 10 years. They all look new. They got the miles. They go some graveyard somewhere. But our boats are lasting way more than 5, 10 years. So what's good for a truck isn't good for a boat, because your boat is going to last way more than 5, 10 years. A 20-year-old boat is not old. So whatever you do on your boat, do it well. So this is basically the technique, and Eric is going to be showing that. And this is really probably the most important thing. Unless you're an absolute pro, and I don't know, maybe Eric does always a pull test, but there's no such thing as pulling on a connector to a cable, especially if it's a gauge 10 or 12. I mean, if it's a gauge 22, a tiny little wire, okay, maybe. But on a gauge 16, 14, 12, you gotta be willing to pull really hard. Make sure that that connection is good. Because remember, practice makes perfect. So you don't wanna go, I'm not gonna touch it, and I'm just gonna hope it works. Because remember, it might work under no load, but as soon as you put a lot of current through that connection, it might be a fire problem. And that's what beautiful looks like. This is on a Catalina. We did a, I think it was a 36, we wired a boat, Catalina 36. Simple, easy, clean, you know. By the way, the easiest way to know if you've got problems with your electrical system without knowing anything, and this is almost a universal truth. If it's not beautiful, it's probably a problem with it. If it's beautiful, I've only ever seen one boat in my life that something was done perfectly, aesthetically, and there was a problem. Now, how many boats have I been on where it looked like a mess and it was a mess? All the time. People that take their SEM seriously, and I'm not talking about having a technical background. It doesn't matter, remember, it doesn't matter what your technical background is. Anybody who takes the time to do something neatly and well is very detail oriented. And that skill translates to doing every single crimp perfectly. The person who does a rat's nest on your boat probably doesn't care about details. And that means that some of the crimps are sort of like, well, I think it's sort of good enough. So I can tell you, without being an expert, you can look at a panel, you can look at anything. If it looks bad, it most likely is. If it looks great, it looks pretty, it's organized, that means that someone took the care to take the time to do it properly. So with that, I'm going to pass the floor to Eric.
So here we have a 14 gauge wire. I'm just going to strip the end off. I'll normally leave about a 1/4 inch to around a 1/2 inch. 1/2 inch is kind of generous. We'll take our heat shrink connector. Always want to make sure 14 to 16 gauge, 14 gauge wire. Slip it on, and I always like to twist with the strands. And notice that there's a little bit of area between the connector and the insulation on the wire. I always like to leave that so I know that it's bottomed out on the end. We'll take our crimpers, start at the very end of one side, crimp it down, and one more on this side to be safe. And do the old pull test. Now I know it's good connection because I can't pull it out. Next, we're going to heat shrink. And I always like to twist around so you don't keep it on one side for too long and you risk burning the insulation off. Okay, pull test again, and that is good connection.